Action!
Have you ever heard of John Nash, who won the Nobel Prize in 1994? If not, then how about the movie A Beautiful Mind? John Nash is the main character of this movie and the most famous Nobel laureate in economic science according to the Nobel Prize Organization. According to them, the prize motivation was pioneering analysis of equilibria in the theory of non-cooperative games, which can be said as Nash equilibrium. Can you understand what does it mean? Although it is really complicated, knowing the basic concept of Nash equilibrium, which led to Nobel Prize, will make us academically be more mature and awake. Thankfully, in this semester, I am learning about this in the class of game theory. Professor Young Kim is the authority of game theory in Korea, and by following his work, I can understand the core point of Nash equilibrium with the example of prisoner's dilemma game. Therefore, I will explain you about prisoner's dilemma game related with Nash equilibrium by setting the game and analyzing simple imaginary situation. Let me begin by setting the basic condition for a prisoner's dilemma game. There is three assumptions. First, each players are rational and acting for self-interest. They know that the other players are rational too. Second, they has complete master plan for the other player's behavior. Third, they knows the payoff or outcome of their selection. So with these premises, let's imagine the situation. Imagine that two prime suspects are under examination in solitary confinement, not knowing the other one's answer. If both of them confess the crime, then they serve 4 years sentence for each. If both of them deny the crime, then they both serve 2 years sentence for each. But if one deny and the one confess, then the one who denies serve 5 years sentence, but the one who confess can get out of the prison. So with this rule, everything is done. The only thing we need to do is to start a game. Let's start a game in the position of each prisoner. First, think of you as prisoner 1. If prisoner 2 confess the crime, then you would like to confess because 4 years sentence is better than 5 years sentence. If prisoner 2 deny the crime, then you would like to confess also because then you can get out of the prison. Then think of you as prisoner 2. If prisoner 1 confessed the crime, then you would like to confess, but if prisoner 1 denied the crime, then you would like to confess also to get out of the prison. As we perfectly predict each player's behavior, let's see the end of the story. You can see that the only max solution of this game is that both suspects are confessing their crime. This is one of the so-called Nash equilibrium. According to the encyclopedia, Nash equilibrium is an action profile that no one can obtain a higher payout by unilaterally changing their selection. They both serve 4 years sentence for each. In addition, why this game is called prisoner's dilemma? You can see that they can only serve 2 years sentence for each if they both deny the crime, although it wouldn't be happen. Each player tries to select their best position for them as you did, but in conclusion, it is not the best interest-giving solution for entire night. Finally, we clearly grasp the well-known case of game theory. By following the game of prisoner's dilemma, you can naturally find the unchangeable optimal option of Nash equilibrium and confirm the dilemma of selection at the end. You can expand this idea in everyday life by various fields. There are lots of examples of strategic situation which is related with Nash equilibrium, like there are matter of sexes, which is about selecting the dating spot between a couple. Furthermore, you can focus on the difference of optimal selection between individual versus entire society, considering the dilemma. Now compare yourself with few minutes ago, even not knowing who is John Nash. You just become a baby intellectual of complicated game theory. Welcome to Game Theory World. The more you study, the better interest you will get. Thank you.